Okay, everybody, welcome back. We have another GoPro up here. It's kind of a small crowd for a GoPro. I don't know. Doesn't everybody want a GoPro? You know you do. Coming up right now, we have Bruce Ross. He is with IBM Cloud Object Storage, and he's going to talk about managing your digital assets, something that we can all use. And at the end of it, we make sure you have a ticket, because we're going to be doing the drawing a little bit differently this time. So hold on to that ticket. That's how you might get a Hero 5 Black Edition. Take it away, Bruce.
Okay, thank you very much. Thank you all for showing up today. It's a real pleasure to speak here at Streaming Media West. Perfect spot. So, first of all, I'd like to introduce myself. I'm the Global Solutions Leader for Media and Entertainment at IBM Cloud Object Storage. We were formerly known as CleverSafe, and CleverSafe has a storage product that I'll be talking about today. I wanted to go into the introduction. First of all, I've been in the media space for 30 years and have been involved with media infrastructure, content distribution, production, media asset management, and so on with a number of companies. So in today's media, we're finding that there's an explosion of media content. I think every one of you out there has been seeing the files grow and grow and grow, and we're building out more and more storage to accommodate it. Second area I want to talk about is the storage fundamentals. What kind of storage do we use today, and how is IBM's cloud offering different? Third, I want to talk about our storage. Fourth is our media applications. What kind of applications are we doing with media companies? Because we do a whole host of applications across different industries. And then talk about our on-prem, our hybrid, and our cloud offerings. We're the only company that provides that kind of thing. And I'm sure all of you are familiar with this scene. And it could be the scene from the Raiders of the Lost Ark, looking for that one videotape. And we've gone through the digitization process. So we went through that a few years back, and almost all customers now have moved to their archives to digital. And what we're seeing is that media data is growing by leaps and bounds. And you'll see it's not only video, it's photos, it's emails, it's rich web content, it's music, and it keeps going 60 to 80% per year. It's incredible. Everyone's got an iPhone or a camera. We're storing more and more of that stuff in our cloud. So going a little bit more, it's a new golden age of content with the streaming video crowd coming on the scene. All the traditional broadcasters said, hey, we got to keep up. We have to make more and more episodic content. We have more episodic content now. I'm sure there are 20 shows you've never heard of that are favorites of somebody else sitting right next to you. And so we're seeing more and more of that on TV networks, on premium cable, on regular cable networks, and now we have Netflix, Amazon Prime, Hulu, we've got Roku and YouTube, and we've also got live sporting events. So there is no shortage of content. Where do we keep all this stuff? Where do you guys keep it, right? Okay, so we've got that problem. And here's one thing that I noticed recently, that Hollywood studios recently discovered virtual reality. It's been around for years, but Hollywood is really doing some investments. Last spring, we saw a lot of investments by Hollywood. Raw and finished content is expanding, and I didn't want to over-dramatize it here, but I think the Atom Bomb is really a good semaphore here, because directors are shooting 20 hours a day for 1 hour of video content, and they'll do 20 to 30 terabytes a day. Where do you store all that stuff? In the past, editors would do compressed editing on HD content. Now they're using 4K and high dynamic range to master. So that generates a lot of intermediate pieces, a lot of renders. There are more versions of finished content. There's collaborative editing, which creates all kinds of content in many locations around the organization. And there's more and more versions. So we've got IMF in Hollywood, and they're creating 20 different versions of the same content. So if you look at the numbers, and I did a little calculation back of the envelope, we can do individual shows in VR or in 4K that are 50 to 100 terabytes each. So an entire season will give you about a petabyte. That's a lot of storage. So anyway, just to hit the point again, if you look at the relative file sizes between 4K, 6K, which Airy and Red are now generating, and 8K, we saw a camera from NHK recently where they're doing an editing system in HK. We did that at, IBM did that at the IBC show. And these are some numbers. And just to give you kind of an idea, the capacity per hour for a high definition is 450 gigabytes raw. For 8K resolution at 30 frames is 26.8 thousand gigabytes per hour. So we're getting to terabytes per hour with 8K. Even 4K resolution is 1.7 terabytes per hour. That's a lot of content. And so on. We've gone from terabytes to tens of petabytes, and that's the whole idea here with all the different flavors in the past 5 to 7 years. Okay, so if you look at basic storage, we had block storage back in the day. It was great, it was clunky, it worked. File storage, we're all familiar with filers, we're all familiar with, you know, you've got all your directories and subdirectories and stuff. That's great for human readable content. But more and more, we're using content management systems, we're using computers to read our content, we're doing analytics. So object storage has come along, which gives you a single flat namespace. Files now become objects that are stored in buckets. A bucket is a URL in a storage system. The content is encrypted when it's written and decrypted when it's pulled back, and we have encryption at rest. So that's the whole concept with object storage, and IBM has mastered that technology. We've seen in the past RAID clusters. Everyone has RAID. They have, you know, I don't want to name any names here, but we're all familiar with our RAID systems and our shared storage. And there's certain things they do great and certain things they do poorly. They're great at high bandwidth and high IOPS. Really good at 2K editing, 4K mastering if you use disk plus flash. Video effects, motion graphics, all of those pieces are great for short-term storage. They're not so great for long-term storage, however. So they're bad at that. Projects that go on hold, you really don't want that on your online storage. Raw source content, you really don't need that on your storage. IMF content, multiple versions, and archive programs and graphics. And once you get past 2 petabytes, RAIDs don't scale very well. I'm sure there are people in the audience who'll give me a big argument about that, but I would say that eventually there's so much data management and so much work that goes into it. So that's why object storage is way better. So a better solution for large Tier 2 and Tier 3 storage. Like I said before, Tier 1 should stay on RAID, should stay on, you know, on your favorite RAID system. So you would have RAID 6 plus replication, and then you would have a mirror of your RAID 6, and then you might even have a backup for your mirrored RAID 6. And there are a lot of customers who actually do this, and it's very costly. So if you look at, if we use IBM Cloud Object Storage or an object storage solution, we can cut the amount of overhead in storage from 3.6 petabytes to 1.7 for your raw, and get the same amount of usable storage at that rate. And that brings us down into the numbers that you would see with online kind of, you know, cloud storage. So one of the areas that I talk about is we instead of using this, having a 3-tier storage arrangement, we have an active archive. Active archive can do all nearline storage and all long-term archiving at the same rate. So you're not moving content from online to nearline to offline and back again. You're not worrying about all of the issues with mechanical issues with your tape library or with your tape machine. You're not always replacing heads. You're not looking for new, going from LTO5 to LTO6 to LTO7. This system will grow with you. And we've got storage management with one piece of glass, 10 nines of availability. The way this is designed with erasure coding, not RAID, erasure coding, we can get 10 nines of availability. We do a 3-tier structure on that. And what we can do is we can start on premises. So if you're an on-prem kind of customer and you feel comfortable having that storage in your data center, no problem. You don't have to go cloud. If you want to, though, you can expand from on-prem to cloud and do a hybrid solution. Hybrid is so important. Now, we can eliminate tape libraries with high latency, and we can do a transition to hybrid cloud and go to 5 petabytes and beyond. We can go to 10 and hundreds and so on. But at least that gives you an idea of where you can start and where you can go to. So where are we in the market trend, right? If you look at the chart, this is a very typical chart for adoption. In 2016, we're still at the early adopter stage. There aren't a lot of media companies who have gotten on the bandwagon just yet, but more and more people in the skunkworks are starting to use object storage either on the cloud basis or wherever. And I think in about another year, we're going to hit the point where it's going to become acceptable to use cloud storage for lots of different storage requirements. So how does it work? Well, let's talk about CleverSafe as a company. The background here is that we started out as, in 2004 in Chicago and shipping products since 2008. So we've got a lot of experience under our belt, lots of customers, lots of references. It's a software-defined object storage. What does that mean? It's object storage that is written in software. So you can define exactly how you protect your content, how available it is, and so on. So you're not stuck to a certain algorithm. It runs on industry standard COTS hardware. So you're not buying specific boxes with fancy bezels. It's just your standard servers, standard storage, and you can either buy ours or you can supply your own and we'll certify yours. And so some notable milestones, we have 400 patents. IBM valued that when they saw our company. And patents are really incredible, and that's what gives us the competitive edge over a lot of our competitors. Gartner recognizes us as #1 in the critical quadrant. We can go to exabytes in production, so we can actually scale up almost to infinity now. In about 5 years, it'll be a very, very attainable number. And we were acquired last year by IBM, and we work with our cloud partners around IBM, and we offer some pretty great solutions. I want to just talk about it. Again, we're on premises, we have hybrid or off-prem in the cloud, and we can sell it in those 3 ways. And if we look at the building blocks, we've got 3 parts. We've got a manager that does all of the software definition. We got the accessor who does the actual slicing and dicing of your data. And then we've got the slice stores. That's the actual JBOD storage for the system. And not to oversimplify it, but we can work with your, if you have a good deal with, say, Hewlett-Packard or Seagate, you can buy the hardware from them and we'll supply the software, or you can buy the whole thing from us, signed, sealed, and delivered. And then we have it's basically, we've got great performance, etc., all the great, bells and whistles. I'm going to skip through a few because I'm running out of time, but how it works is your data comes in to the accessor slices it up. On the left side, you'll see that we have a 12 wide, basically 3x4, and we can slice it up. We can actually lose 5 out of the 12 slice stores and still be in operation. And so it's kind of like the mathematical coding is like, if you remember algebra, you had 5 equations and 5 unknowns, and you could uniquely solve those equations. We give you 8 equations with 5 unknowns, and that's how we get to this point where we have 10 nines of availability. Quickly, we can start small, and then we can add accessors. and we can add more storage. And we can do this while the system is online and live. Because we can drop storage and we can drop accessors, we can actually do upgrades of the software while the system is running. And we never skip a beat. So how can we put it together for you? These are the types of customers that we talk to. TV networks, cable, Hollywood, etc. We also talk to service providers, cable and satellite, telcos, folks with user-generated content, social networks. There's a ton of video on social networks, online publications, a lot of different areas. And then basically, what are our applications? These are the typical applications we run into. We have media production playout. So we have integration with Avid and Adobe editing. So we take the raw source content, we do the finished content. We do content archive and backup. So if you've got a big LTO library somewhere, we can begin to replace that and begin to upgrade that. We work with cable and telco, MVPDs, cable systems, and we have a cloud DVR solution where we keep a single copy of everyone's DVR selection in the storage. And also user-generated photo, audio, video content. So if you think of all the popular websites, we're in a lot of them. So where do we store all our iPhone videos? Right here. Social networks, here, rich media content. Some more key applications is kind of a similar kind of thing. And then we talk about user-generated content. You think about Hollywood, there might be 20,000 publishers. User-generated content, there are billions of publishers. And this content is where we're seeing the biggest growth. We work with a lot of your incumbent products, so editing, archive management, tier 1 storage, ingest, media asset management. We work with a lot of these companies and a lot more that I couldn't fit on the chart. Sorry about that. And so what are the reasons why you should go with us? Total lower cost of ownership. Much lower cost per terabyte per gigabyte than RAID storage. We scale up from petabyte to exabyte. So if you ever get to a point where you can't go any further with your RAID, we can take it from there and keep going. Hybrid storage, we're the only company that offers on-prem and off-prem storage with hybrid. We have built-in security, and that's really important. When we do the striping and the spraying of data, we're also encrypting that data. So if anybody finds your disk drives and tries to get your information, no way. There's no way they're going to be able to pull it out. We have cloud storage economics. So we've got multiple ways of providing it. We've got a high availability, we've got lower availabilities, we've got high throughput, lower throughput, and we can provide your a price that fits your pocketbook and application. And lastly, there's not a mirror. We don't have a main copy and a backup copy. Because it's sprayed across with those 8 equations and 5 unknowns, we never lose a drop. There are, I think, more grains of sand in the universe than there are lost bits in our system. So, and it sounds like baloney, but we actually have the data to back it up. There are no black boxes, and we work with Amazon S3 API, OpenStack Swift. We've got a couple of other interfaces. And I'd like to thank you all for coming in. And if you have any questions, please let me know.
All right, got some questions here. You want to applaud? Go ahead, applaud. You did a great job. All right.
Well, thanks very much. And now I'll turn it over to the drawing.
Well, hold on. We must have a few questions. We always have questions, right? Anybody who's got their hand up? Somebody? Nobody? Did he answer it all?
Challenge me on the 10 nines? Come on.
Anyway, you want to open it up? Should we ask about the election, the economy? All right, we have a question.
So it sounds like it's more of a RAID and kind of like user space software, right? Not necessarily a RAID, but kind of accomplish the same thing without the scaling problems. Is that correct?
Yes, yes. We have, to paraphrase, it sounds like a RAID, but it's more than a RAID. We use erasure coding, which is a different type of algorithm. We have a similar technique, but RAID replicates disk drives in a cluster, and we replicate the slices of information that get sprayed across the multiple disks. So if we lose an entire disk, for example, we've got that information redundant somewhere else. So that disk goes out of service, and we'll just take the information that was on that disk and push it over to another location. And so our accessor handles that.
Have you set up any of these systems for any government, law enforcement, or high security agencies? And what have been some of the challenges that you've run into?
That's a great question. Do we have law enforcement? Do we have security camera, and so on? We have a group that is dedicated entirely to federal and state government, and I can't tell you what they do because they won't tell me. But there's an awful lot of data that they work on. And we are doing security camera video. Security camera video is growing by leaps and bounds, as we all know. Every street corner's got a security camera on it. Police officers have body cams and so on. And we are working with those kinds of customers, absolutely.
Okay, that is the time. All right, and we are off again. We have two presenters this time, both representing the Digital Watermarking Alliance, and they're going to be talking about enabling scaling watermarking. If you have premium content, you need to protect it. And Niels, who is with Verimatrix, and Mark, who is with, he's a fill-in with NextGuard, not in the program, are going to be talking about watermarking. And at the end, everybody can be a winner because they've brought a lot of color change mugs from the DWA, and we can all come down and get one. All right, take it away, guys.
Thanks, Troy. Hello, everybody. Welcome to our presentation on an industry collaboration on standardization to foster digital watermarking. My name is Niels Thorvers. I'm VP Advanced Technology, a research with a focus on watermarking with Verimatrix.
Yeah, and I'm Mark Nakano. I'm the Senior Director of Product Marketing and Partnerships. We also focus on forensic watermarking.
So yes, we are competitors. You don't often see us in the same stage. Today's different. We are presenting work we did together, and one of the organizations that we joined to foster watermarking, to explain common problems on areas that we don't compete in, is the Digital Watermarking Alliance. So you see our logos here. You also see Content Armor on the left, who also contributed in what we are presenting today, and we have Alan here as a representative. And there are other companies that do digital watermarking. Who has been in the other panel on digital watermarking? There was one just 40 minutes ago. Not too many. Graham, of course. So it might warrant to give a brief introduction on digital watermarking. And let me show you a sample that everybody has in the pocket. This is a $20 bill. And of course, it has a watermark that's done by washing it, that you can see through light. It also has a digital watermark. If you look at it, in the back, it has a little 20s, little yellow 20s. It's actually a digital watermark. A scanner will recognize it, a photocopier will recognize it, and block the photocopying. It's a little secret that the Secret Service actually doesn't want you to know. It's to block casual counterfeiters. And it's like watermarking, it's a machine-readable code. But unlike what we are talking about today, it blocks you from doing something. We are talking about forensic watermarking, which doesn't block you from doing anything. It's there to trace piracy. So we embed a number into a video in order to know where it came from and if somebody leaked it. To do that, we need to be invisible. Top left, fidelity. We need to put a signal in there that's invisible. Nobody can see it, not to degrade your consumer experience. In the same time, we need to be robust. We need to survive. That signal need to survive a lot of degradations up to, including camcording, which is a significant degradation to video. So then it's about putting a bunch of bits in there and having a certain amount of time to get them out. That's sort of the art of science of watermarking and doing that securely.
And then today, as you can see, we have watermarking in all facets of different workflows, different products. One part that I kind of wanted to focus on that kind of affects everybody in this room is really the theatrical watermarking or digital cinema. So today, if you actually go and watch a movie in a movie theater, that video is actually watermarked. So there's actually data in the video. So if you actually sat there and camcorded the video and then distributed it as a pirate, if it's found, we can actually trace it back, and we can trace it back to which theater and which screen and everything. That's kind of what we do. So that's how like watermarking is actually affecting like everyday life. And another area where watermarking is highly used is in this content lifecycle, right? So the content lifecycle, you have production, post-production, you actually have initial release when it's actually shown in the theaters, and then you finally have delivery to the consumers, or pay TV cycle, right? So in the pre-release time, which is basically during production and post-production, the movie is actually being worked on at this point. It's not released. It's, they're doing a lot of editing, they're doing special effects, all that kind of stuff on it. So what the studios usually do is they watermark everything before they send it out anywhere. So if they're going to send it from one post facility to another, they'll watermark it. If they're going to screen it for critics, they'll watermark it. So this is where you're always seeing these things where something gets leaked by a press critic, and we can actually trace it back to who was the one that leaked it. And then you get to digital cinema, which I talked about in the previous slide, where you are now showing it in the theaters. Everything's watermarked. Everything can be traced back. And then when you actually get out of that digital cinema window, there's something that's happening today, or we'll start seeing more in the future, something called early release. And so what early release is while the movie is playing in the cinema, it's also offered on other platforms to the consumer, right? So it could be offered, let's say, from like a DirecTV or a Comcast at the same time as it's in the theater. So that's early release. So with these kind of new areas, what's happening is when it gets delivered to the consumer, we're going to talk in the next slide about better content also. This is causing security requirements to become greater. So watermarking is actually in this enhanced content protection spec that was done by Movie Labs. And these are kind of the new, harder security requirements that are required for premium content. So I'm going to talk about two trends in the industry that we're seeing today. And basically the two trends are better content and earlier content. Those are the two trends. So what do I mean by better content? I'm not sure if there's a bunch of acronyms, UHC, HDR, WCG, HFR. So what that means is your content is getting better and better. So you have ultra high definition content. What does that mean? You have more pixels, higher resolution. That's great, but really the big difference right now is we have something called high dynamic range, which is HDR, high dynamic range. If you look at the picture that's up there, if you look on the right, that's kind of standard dynamic range. I'm not sure how well you guys can see this, but the illustration is the part on the left is high dynamic range. So you can see that it's more vibrant. Basically, you can think of high dynamic range as being better pixels. And what high dynamic range really is, a real simple explanation is you have darker darks and brighter brights, and everything in between is enhanced, right? And then another important thing we have is wide color gamut. And what that allows you to do is it basically expands your color range from like 256 colors to over 1,000 colors. And then the last part of the content getting better is actually high frame rate. So in cinema, we've seen frame rates usually go from 24 frames per second to 48 frames, which was what The Hobbit was shown in, to 60, and now there's a movie coming out by Sony that's 120 frames per second. And this really affects motion. So the motion that you see on the screen with high frame rate becomes more real, more realistic. And the second trend was earlier content. So I briefly touched on this in one of my previous slides, but basically earlier content is so all the studios are releasing content while it's also out in the theaters. So we're seeing that trend happening, coming up soon.
So what does it mean, studios putting out better content, break with the previous way the pixel brightness was regulated? One of the things is higher security levels, as Mark mentioned. And so there's a Movie Labs studio organization that published specifications for content protection requiring digital watermarking for Ultra HD content. High resolution, better pixels. So that's a requirement. That's where we see a lot of traction on digital watermarking and how to implement it. We're fielding a lot of calls on how to supply that for a variety of networks, including OTT and streaming, which is often at the forefront of some of those innovations. Before we get to how that is accomplished, maybe a little bit of a history on digital watermarking, which I've been in for 15 years, starting at the very beginning, where it initially was about creating technologies, just the algorithm on putting information in there that survives transformations, which is hard, which is part of the science and magic to make that invisible. But that doesn't create a technology that you can use. It's an enabler, but you still need to implement it. First step on that was to make it very fast, maybe around 2005, to put it in set-top boxes. Single-use devices that haven't been designed to process a lot of pixels, yet we are trying to squeeze in an algorithm that modifies them, and that's a big challenge that we have overcome. All of these, by the way, are still ongoing, and we are refining that, but those were the different steps if we needed to put a stake in the ground to define those. Adaptive streaming came along, big challenge. How do we mark different bit rates if you want to give that out from a server and deliver uniquely marked stream? We're going to talk about that. But mainly what we talk about is the final step to standardize it, to allow different industry players to adopt adopt digital watermarking, and make that scalable. That's a big effort, and that's what we are currently working, and we are showing some results of that, presenting it here.
So one thing that we started to do was there's a UHD Forum Security Working Group where a lot of our member companies are a part of. So basically, you can see a lot of our competitors got together. I mean, part of the reason why we're doing this is we're seeing watermarking requirements being more ubiquitous, and they have to be. It's basically going to be a point where there's going to be more watermarking on more devices, on more distribution platforms, and everything. So we see the need to do standardization in order to get this deployed. So you can see from our working group that we have, our competitors, Content Armor, Erdeto, NextGuard, Verimatrix, we all got together to actually start working on these standardized specs. And what we actually looked at, three main points. So the basic watermarking interface points are during video preparation, so on an encoder, so we actually looked at defining some specifications at this point. Also during video distribution, and Niels alluded to this earlier, but when you're distributing this video, most of it's across the CDN. So we're looking at how do we build watermarking into a CDN? And then finally, at the device, you can actually do watermarking at a device. So we're looking at all three of these points and actually creating some open specifications to be so that each of these players can implement some type of watermarking. And I just want to let you know that on this UHD Forum Security Working Group, it's just not just limited to just the companies listed. It's whoever's a member can actually participate. And part of what we're trying to do here is we're trying to do a little bit of outreach also to say, we welcome external participation, because when we're defining things like on the video distribution CDN, we're not getting necessarily input back from the CDN vendors. So we would love to get more input to make sure that what we're defining is something that will work. And so now we're just going to kind of get into a little bit of the details on the different watermarking technologies that our companies, well, actually all of us probably implement. So one of them is called one-step watermarking. And like the title implies, what does that mean? That means you do watermarking in one step, in one shot, right? So normally you handle this either on the encoder or on some kind of playback device during the in using the secure video pipeline to guarantee security. So what does that mean? That means that you actually either look at a transcoder or encoder and you have to do an integration with it, or you integrate directly on the device or on the client, right? And so the advantages of doing this is it's actually independent of any kind of codec or any kind of delivery mechanism that you use, because basically you can uniquely watermark everything either coming off of the device or before you send it. It's very scalable. And then there's no overhead during delivery. So what that means is some watermarking technologies cause you to increase the size of the file because you're adding some watermarking, information. With this one, it's if you have a 1 meg file, it's basically a 1 meg file that gets sent to you.
Yeah, so that's a fundamental way of doing it, just modifying the pixels and see where we can integrate it in the encoding step or decoding step. Now, how we modify the pixels, that's our respective secret sauce. But that there's the option to do it in one step and something to consider, that's something we all field in the first calls. So that's something we're sharing here. Now, that's a simple approach, right? You get the video, you get it in baseband, YUV content, you modify the pixels, and you have a uniquely marked stream. I think that's sort of where watermarking started, and that's ideal if you can do it. Either on the head end, you prepare a few files, but you need to re-encode it with every file. That's why it doesn't scale well. You can't do that a million times. You can do it on the client because every client decodes the content, and if you're integrating it there during decode, you can modify the pixels and embed a mark. And that's what we are doing as respective companies. However, there are distribution mechanisms, scenarios where you cannot get into the decoding pipe. You cannot be integrated in a device. Maybe it's already out there, it's bring your own device scenarios. You need to try to do it from the head end. And that requires to deliver a uniquely marked stream without modification on the client. That's tougher, but it's possible. And the basic approach, and here again, that's more of a standard on how you fit individual technologies into it. The basic idea is that you pre-process the content one time. That includes decoding. You look at the pixels, you want to know where you can invisibly modify them, where you can apply things that you store the data without anybody noticing it. So you decode it, and then you recompress a certain section of it, what we call variants, sort of an industry term, where certain areas of the file are encoded twice. One version signifies a 0, the other one a 1. And like this you have a choice, a binary choice to embed 1 bit in this location by swapping out content on this location. Which brings me to the embedding. So that's a pre-processing. You create those variants. Now actually on the embedding step, you take a file and you choose whether you, in the first location, whether you choose the green box or the blue box to embed a 0 or a 1. And so you create two different files, 0, 0 and 1, 0. And since you're only working on the compressed domain, potentially even encrypted domain, you can do that very fast. You don't need to decode, you might not even need the decryption key, you just replace an area of the file. And that area can have different sizes depending on the technology. It can be a few bytes for macro block, it can be a slice, it can be a frame, it can be a whole group of pictures. It's just an area that you encode some kind of information. Here it's binary. Okay? Now that enables you to make it scalable and fast. Now let's look into the different scenarios on the way the content is distributed. In a simple scenario, you have just-in-time server embedding. Somebody requests a file, you apply a quick modification, and you send it out. Right? This works on an entire file for progressive download. It also works on just a chunk or segment for adaptive bitrate streaming. However, you need to have some server intelligence, and that's where watermarking squeezes in. The server just wants to crank things out, and here we are, want to modify something. But we have reduced that something to a very small amount. Alternatively, you can just have a stack of files, and you give them out as somebody requests them. So that makes it very easy, but you need more storage space. It doesn't scale so well. A somewhat hybrid solution is using the playlist to actually do the embedding, where you give individual playlists to the recipients. So you have two playlists, 0, 0 and 1, 0. And as you see, they point to similar chunks, same chunk in the first section, and then different chunks in the second section. And that's how a playlist will automatically assemble a uniquely marked stream. That works with HLS type templates where you can actually reference individual streams. Otherwise, you can put a proxy in the middle that will point to the right stream and chunk for a given playlist. So that makes it easy in that the CDN can remain just the data storage and just delivers the segments that are requested. Now, the last variation here is a client device embedding where a client gets the content and also the variants and then modifies them accordingly. So you need to trust the client, and the client needs to be secure for that. One way where that can be done is media delivery, for example. And one standard that exists around this already is the MPEG variant standard, where it outlines how to store and secure those variants and then apply them.
And guys, we are going to have to wrap this up now. I'm afraid we're at time. Do you want to quickly conclude?
Yeah, thank you. And that's, that's the last slide. One closing remark. This is a document we created now with the Ultra HD Forum that's going to be public soon. It's just in the process to be sent to other companies for comments. So that's a first start, and then we're going to define more of the workflow, possibly APIs later in this group.
Terrific. Round of applause for Niels and Mark. Thank you.